Start.
The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone. Welcome to this webinar Data Science 101 organized by Prima Consulting. I am Suman and I'll be your presenter today. Before starting, a little background about me. I came to data science from statistics background. I have a PhD in statistics from Monash University and 4 years of research experience in geospatial statistics. Currently, I'm working as a data scientist for a Perth-based client of Prima Consulting. So with this webinar today, my goal today is to introduce data science from a very practical standpoint. As you may know, data science is a broad area ranging from abstract theory to very applied methods, even rule of thumb in many cases. So for today's webinar, I'll keep away from technical terms and will mainly focus on the applied part of the process. So the main idea is to get obtain business insights and actionable insights from large amount of data and how we can do that using data science. So let me go to today's agenda. I'll start with a brief introduction to data science. After that, I'll talk about 4 data science solutions across industries. Then I'll show you how a data science project lifecycle works. And finally, I'll present a case study which I've recently worked on for a client who is in the energy utility space. So let me start by what is data science. So when we talk about data science, most of us think of the advanced algorithms we use to extract information from huge amount of data. That's what we think about. And most of these algorithms are actually ideas and methods developed in different fields like mathematics, statistics, machine learning, engineering. This is the analysis part. So this extracting information from data, this is the analysis part of the whole project. And of course, undoubtedly, this is the most interesting bit. But large amount of time and effort goes into collection, into data collection, data cleaning, and at the end, data transformation before actually we could start analyzing the data. So I'll talk about the data lifecycle, all these steps when I'll talk about the data lifecycle, data science project lifecycle a bit later. Now let me introduce 4 data science solutions across different industries. So product recommendation for retail industry, whoever has shopped online must have received emails afterwards with all kinds of product recommendations. So online retailers use customer information and their purchasing history to predict what is the product each customer gonna purchase next. They use similar techniques to send personalized coupons, deals, and offers also to first-time website visitors so that they can turn into a paying customer later on. In banking, credit scoring is a very common business problem. So bank uses their clients' data to predict the likelihood of a client's default, and this credit scoring is actually used when you apply for a loan, whether your loan will be approved or declined, depending on your credit score. Churn prevention in many industries is also an important problem which data science can solve. Many customers, not all customers will always complain when they're dissatisfied. They'll just leave. So by using your customer database, you can predict which of the customers are at risk of leaving and hence decreasing the attrition rate in your customer base, and that actually helps your bottom line at the end. Customer segmentation is also an important topic, and I have actually worked on customer segmentation very recently. I'll mention it in my case study in more details, but the idea is to group all the customers into separate clusters, into a number of clusters, so that within each cluster the difference among the customers are not much, but between clusters is quite big. And then depending on some characteristics, we want to cluster them together. So in case of this energy company, they wanted to cluster their customer based on their daily usage profile, how each customer using electricity every day. Based on that, they wanted to group these customers together. So let me now go to the project life cycle, and you can so that it starts from left to right, and the arrows are defining which one comes after which one. So any data science project start with asking a lot of questions to your client. What is the objective of this project? What sort of data we have in the company or in the business, and can we obtain extra data set going abroad, going externally? In my own experience, we are now going externally to get many property data for our customers from many. There are many websites and companies who are selling data, property data, and all sorts of information data. So you can contact them and get hold of that kind of data, and then you marry that data with your internal database to build a really good predictive model. Once we obtain the data, then comes the part where we have to clean the data. We have to then we have to do some kind of exploratory analysis to create a plan. What sort of model we're gonna use? We're gonna start analyzing, and then we look if any kind of transformation required for variables, or do we need to create new variables from already existing variables. We have to make that sort of decisions. So once we have all the variables sorted out, then we actually split the data into two sets, train and testing set, and then we train the model on the training set, which may be 80% of the data, and then we test that model on the testing set, which is 20% of the data. You leave out for testing. You don't use that data set for training because of the reason, something called overfitting in data science. Once you test it, you try another model and you repeat this last two or three steps, the splitting the data and training testing to choose the best model. And once you have a model which you can trust, then you deploy it all over your business. So that's, in a gist, how a data science project lifecycle looks like. Now, let me give a case study which I worked on, worked for a client who is into energy utility space. They wanted to do a customer segmentation based on customers' daily usage profile. So you can imagine if you have hundreds of thousands of customers, their daily usage, and I'll show you how the data is cleared. So we have 15 minutes data for each day, so 96 data points each day for each customer for, say, last 2-3 years. And the whole idea is to group them based on their behavior, whether some of them are daytime user or some of them are using the electricity mostly after evening, or it's a business which using electricity all over the day. So all that sorts of questions they were asking. So some of the end goal was to sell solar panels to these customers, and we will see that customer segmentation helps to make those sort of decisions. So this is how the journey of the data looks like. So the data comes from smart meter, and it's 15-minute interval data for each customer, and it goes to our data center via access point via 3G network. So this is the end product for a particular region looks like. So once we have clustered or grouped each customer, you can see we ended up with 6 prominent clusters or identifiable clusters in this case. You can see bell-shaped ones will be really good for selling PV or solar, and the evening bump, the down here, will be really good for selling solar panel and battery. The bathtub shaped in the top middle part might tell you that they already have PV installed from that shape. A flat, people, you might want to ignore them for selling solar panels. And so this sort of business decisions we can make from a customer segmentation solution. Let's go to the next slide, and I'll just pointed out all these business insights we can get from a customer segmentation solution. So the main question, the big question was that which customers to target for the solar panels, and you can see that the customers with the bell-shaped pattern are the prime candidate for that. We wanted to, again, business wants to sell solar and battery, maybe at some point in future. So the evening bump would be a good candidate for that. we can identify the customers who already have maybe solar installed with bathtub shaped, and we might want to ignore the flat ones because they won't be incentivized to put on solar because their profile doesn't suit that taking up that cost. And also, I mean, one important concern for the business, this is for another product, that what are the customers who can shift their peak load after 8 p.m.? So this is also one question business is asking. As you can see, the customers in the bottom, they are likely to shift their load, or they can shift their load after 8 p.m. if they're properly incentivized, if they give incentive. So I'll just quickly talk about the data transformation, how from daily 15 minutes interval data, as you can see, it's 15 minutes interval, 96 data point for each day. We ended up well-defined 6 clusters. So for each customer, we ran monthly clustering, and for each customer, the top left plot shows the 30-day usage, and since we are only interested in the shape of the curve, we standardized it, we normalized it, and made it between 0 and 1 without losing the shape of the curve. And then from 30-day plot, we took the median at each interval to get an aggregated profile for that customer, and that aggregated profile went into the clustering algorithm, and we inserted all these aggregated profile for all customers into clustering algorithm and ended up with 6 well-defined clusters, as you saw. Let's talk about some of the tools we used to get to this solution. So the data coming from smart meter system, this got advanced metering infrastructure, AMI data, we call it here. So it's smart meter, 15 minutes interval data, and we store it in a database. Then using SQL or SQL within R, we extract the data into our server, which has immense memory and computing power. And there we run our clustering algorithm. And once we label each customer with a particular archetype, we again write it back to our database so that business, the people who are building visualization tool or using Power BI or some other tools, they can use that data to create nice visualizations. So to end this presentation, I just broadly categorized all sorts of algorithms in data science into 5 broad categories. I mean, 95% of the problem you will encounter in data science will come under one of these umbrellas. So regression, clustering, classification, dimension reduction, and graph algorithms. These are the main 5 categories I would say you would find your problem fall into. Regression, I think most people know what it means. Classification also, whether you'll get your loan approved or not. So that's a classification problem using credit scoring. Clustering, we just looked at a clustering problem where We try to group customers based on their daily usage profile. Dimension reduction is when you have lots of variables and you want to only pick, say, top 20 variables which has the most predictive power of predicting something. Then you want to reduce the number of variables. So that's common dimension reduction. It increases your predictive power as well. Graph algorithms are when you don't have a well-structured or tabular database, when you have different relationships between different people and people representing nodes in the graph, and the relationship is by edge connecting to nodes. That sort of analysis, network analysis, can be done using different sort of graph algorithms. And thank you. I'll be happy to take any question right now, if you have any question.
Thank you, Suman. So again, if you have any questions, please type it in the box on the right side corner. Then you'll be able to ask Suman on any data science question that you are thinking at the moment. We have a couple of questions that come in, and let me just organize the questions so we can know what to ask. So the first question, can you tell us another project that you have worked on?
So another project we have worked on is recommending customers what solar panel size, the PV size, system size they want to install. So for each customer, we have predicted using their usage data what solar panels, what system size they should go for, and then we calculated their expected bill under that solar installment. So our customer service people are using that to market different products around solar panel.
Very good. And then another question, do you prefer R or Python for data science? I think this is asking for your own personal preference and what kind of language you like to use.
We are using R right now for our clients, and I think R and Python both are good. I'm very experienced in R, so my bias will be towards R. But if you're coming from an object-oriented background like C++, C#, you might like Python because that's object-oriented as those languages. R is more functional programming. If people are interested in that sort of background, you create many functions to do stuff. But both languages, the attractiveness is that they both have huge number of packages and libraries you can use for all sorts of data science solutions. So it's really boils down to what your client is using, and and after that maybe what your preference is.
And Simon has asked a question, what about Spark ML instead of R or H2O?
Spark, did you say Spark?
That's correct, Spark ML.
Yeah. So we are trying to like go for Spark. So these are all big data solutions. If you want to do parallel processing with distributed system, HDFS, Hadoop distributed system kind of stuff, where you distribute your data into different segment and then calculate, and then once you calculate each segment, you again roll it back to reduce it back to get your final solution. So we are looking into that sort of solution here, but haven't started implementing it or deploying it. It looks, yeah, so business is looking into that here. at our client's base.
Mhm. So, is it correct if I just put it in? I mean, you use different Python, you use R, and Spark ML for different purposes at different situations. Is that what it is?
Yeah, these are all big data solutions. I mean, if you have dynamic data coming through very quickly, large amount of data, and you want something to be done with real-time analysis, then these are good solutions. But right now, we are here are mainly the data set is large, but it's static. So it's sitting in the database, and we are extracting it from there, and we have our server and which has huge computing power, so everything gets done very quickly anyway.
Mm.
So, but I think depending on how much money you want to invest in your in your data science and everything, I mean these are quite expensive tools.
Mm. He also asked about H2O. Is that in the same big data kind of language?
H2O, are you talking about the package H2O in R?
Simon, can you clarify the question, please? Is that in R that you're
I
looking
think
for
there is
in
a
H2O?
package in R of H2O, but I haven't used it that much.
Okay. Okay, cool. So again, if you have any questions, we have 3 minutes left. Please type it into the box, and then we'll ask the presenter on the question. Okay, so another question. What was the part that took the most time?
Sorry?
What was the part that took the most time? Probably need to clarify a little
I
bit
mean,
further. I think maybe based on what you have mentioned just now.
yeah, in the project life cycle, right? I mean, data cleaning and data transformation, data wrangling, they call it in the industry, that takes a lot of time, almost 60% of time takes. I mean, imputing, missing observation, then writing code to transform the data, that takes quite a bit of time. Then you have like many data integrity problems here. Uh, Matching meter with proper customers, because customers could have multiple meters and multiple meters could have historically many customers attached to it. So all these sort of problems comes up once you want to create a total solution around a problem. So yeah, that takes time, and maybe 20% of the time actually goes into writing the clustering algorithm, and then actually looking at the answer and figuring out what we are looking at, what results we have got, and that sort of stuff.
Mm. He asked what about the prepping data and finding the right model? Does it take a lot of time as well?
Yeah, it does. I mean, if you are working with a very complicated database tables, I mean, we have multiple tables in database. You have to join them properly and that sort of stuff. So it takes time to do that.
Awesome.
And once you have the data in the structured format, then you can implement any kind of algorithm these days.
Awesome. Okay, cool. So we're running out of time. Thank you everyone for joining. This webinar recording will be made available after this webinar. If you would like to revisit again, please let us know at info@prc.com.au. Thank you very much. We'll end the webinar now.